Let's do one question and then I will move on to another topic. Okay. So there is a question in your NCERT. Right. The question is complicated, but if you slowly read the question and understand it, it will be easy for you guys. So they are saying during a nuclear explosion, one of the product is strontium 90 with a half-life of 28.1 years. With a half-life of 28.1 years. Then they are saying if 1 microgram of strontium 90 was adsorbed in the bones of a newly born baby instead of calcium. थोड़ा इसका biology हम बता देते हैं आपको. So bones, they have a property that they absorb calcium. ना bones में calcium होता है. Now calcium, it is present in the form of iron, and we know that calcium, the ionic form will be calcium 2 positive. The strontium is also in the same group. Be makka sar bada, right? Beta mange car scooter. That scooter thing is strontium. So strontium will also going to have 2 positive charge. That is why it is easily adsorbed in the bones instead of calcium. ठीक है, calcium की जगह strontium को adsorb किया जाता है. Now this is the biochemistry of it, but we don't have to worry about it. Next they are saying how much of it will remain after 10 years and 60 years. दो टाइम दिया हुआ आपको. 10 साल बाद कितना रहेगा और 60 साल बाद कितना रहेगा. इफ इट इज नॉट लॉस्ट मेटाबॉलिकली, दैट मीन्स अगर वो हजम नहीं हो गया ना, इफ द बॉडी इज नॉट यूजिंग इट, then how much of 90 strontium is going to be present. Now the first thing about 90 strontium 90 is that it is radioactive. Okay, there are few points that I want to write. Now this is prerequisite information that you should know, that strontium and barium, radium, all of these are what radioactive elements. 90 strontium is radioactive. Now guys, can you please turn the camera on also? Radioactive. And the अच्छा radioactive है तो the radioactive decay, it is a process and it is reactant and product उसमें होता है. radioactive decay follows first order kinetics. Okay, it follows first order kinetics. Yeah, guys, can you please have your cameras on quickly? Amna, Aisha, Parker, Mir, Raba and Sidra. What happened, guys? I'm waiting for you. Amna, Parker, Mir and Raba, Sidra. Okay, Sidra is okay. Fine, Raba. Okay, thank you, Amna. Mir, I'm waiting for you. Mir and Parker. Mir and Parker. Please quickly turn your cameras on. Okay. Now 90 strontium, it follows the first order kinetics. ठीक है. अब देखिए यहाँ पर उन्होंने क्या दिया हुआ है. They have given the T half. Since they have given the T half as 28.1 years, we can find the K also, because we know the relationship T half is equal to 0.693 divided by K. Therefore, we can say that K will be equal to 0.693 divided by T half, which is equal to 28.1. The unit will be year inverse. Now, this is the rate constant that we have found. They are saying how much of it will remain after 10 years. Okay, the time they have given us 10 years ने पूछ, देखिए उन्होंने बोला है कि ए नॉट कितना है. इनिशियली हाउ मच वी हैव 1 माइक्रोग्राम, 1 माइक्रोग्राम. And they're asking the amount of strontium remaining after, ये पूछा हुआ इन्होंने, after time they have given as 10 years. 10 साल बाद कितना होगा? So we can simply use the formula KT upon 2.303 is equal to log of A naught by A. Correct? हमारे पास K मौजूद है, right? We have the K, we have the time, we have the A naught, we have to find just the A. ठीक है, ध्यान दीजिए जरा. How to do this? Now, what is the K we have found right now? K is equal to 0.693 डिवाइड बाई 28.1. ठीक है, यहाँ पे बहुत सारे लोग ना पहले हमसे पूछ रहे थे सर ये मतलब सेकंड्स में कन्वर्ट करना है क्या, मिनट से सेकंड में कन्वर्ट करना है. तो देखिए, एज यू कैन सी दैट टाइम इज गिवन इन व्हाट, टाइम इज आल्सो गिवन इन ईयर्स, है ना. एंड द रेट कांस्टेंट इट इज आल्सो इन ईयर इनवर्स. करेक्ट है ना. तो इस वजह से सिंस बोथ द यूनिट्स आर सेम यू डोंट हैव टू कन्वर्ट एनीथिंग. नाउ this is my K, which will be multiplied by 10 and then divided by 2.303 as it is, 2.303. This is equal to log of A naught. A naught is equal to 1 divided by A. Now we have to solve this part. If you guys remember slightly, I said that you can approximate 2.303 and 0.693 as 3. I mean, wait a second, not like this, but rather, first I will multiply 0.693, I will get 6.93 divided by 28.1 into 2.303. 2.303 multiplied by 2.303 multiplied by 3 is approximately equal to 0.693. And log of 1 upon A, I can write this as minus log of A. This is using a property of log. How you can solve this? Log of A is equal to minus 3 upon 28.1. 3 upon 28.1. Can you find this value? What is the value here? 3 upon 28.1. इतना कॉपी करके tell me the value of minus 3 upon 28.1 in the chat. Yes, Sidra, very good, correct. हाँ करेक्ट, सिद्रा है नाम ना, वेरी गुड. बाकी लोग का आंसर नहीं आ रहा है. Amna, you just forgot the minus sign, but log A will be equal to minus 1, sorry, 0.106. ठीक है. एंड देन आपको या तो डायरेक्टली वो दे विल गिव यू इन दी व्हाट आई कैन सी इन द क्वेश्चन इटसेल्फ. अगर बोर्ड्स में आएगा तो दे विल गिव यू द एंटी लॉग वैल्यू आल्सो, है ना. ऐसा आपको दिया रहेगा एंटी लॉग ऑफ -0.106 इज इक्वल टू दिस मच। बट मान लीजिए आपको फाइंड आउट ही करना है ना। तो देखिए हाउ टू कैलकुलेट दिस टाइप ऑफ वैल्यूज, ध्यान से देखिएगा, प्लीज डोंट राइट एनीथिंग। We know that the concept of log revolves that this is a base 10 to the power minus 0.106 will be equal to 10 to the power of इतना will be equal to a। हम यहाँ पे ले सकते हैं a जो होगा दिस विल बी इक्वल टू 10 टू दी पावर माइनस 0.106। ठीक है गाइस, ये सुनो प्लीज टेल मी, दिस मच मेक सेंस? बोलो भाई ये सुनो।
Yes, sir.
यस ना, ठीक है। नाउ द नेक्स्ट थिंग इज वेरी इंपॉर्टेंट, जो कि इसको रीअरेंज करके लिखना। यू हैव टू राइट दिस माइनस 0.106 10 टू दी पावर नेगेटिव है ना, तो उसको रीअरेंज करके हम क्या लिख सकते हैं, देखिए आई कैन से दैट 0.894 माइनस 1 विल बी इक्वल टू माइनस 0.106। अब करके देखिए एक बार, आपको क्या लिखना है, माइनस साइन जो है ना, -0.106, यू हैव टू राइट इट इन दिस फॉर्म। ठीक है, जो भी नियरेस्ट इंटीजर है, दिस इज अ डेसिमल पॉइंट ना, दिस इज अ डेसिमल, डेसिमल के बाद कौन सा इंटीजर आ रहा है, 0.10 के बाद कौन सा इंटीजर आएगा, 1। तो -1 इंटू समथिंग, आई मीन 1 -1 प्लस समथिंग आपको करना है और इस फॉर्म में लिखना रहेगा। ठीक है, दैट इज द फर्स्ट थिंग दैट यू नीड टू डू। अब देखिए इससे क्या होगा, फ्रॉम हियर यू कैन राइट that a will be equal to 10 to the power 0.894 minus 1। ठीक है, this I can write further as 0.10 to the power 0.894 into 10 to the power minus 1। करेक्ट है गाइस, सुनो प्लीज टेल मी। अरे बोलो भाई, ये समझ में आया यहाँ से यहाँ, 10 to the power a into 10 to the power b is equal to 10 to the power a into b, sorry a plus b, my bad, a plus b ना, करेक्ट है?
Yes, sir.
वही तो हो रहा है। फर्स्ट समझ में आ रही है सबको, ये सुनो प्लीज टेल मी। अरे बोलो भाई, रबा आपको नहीं आ रहा क्या? भाई आंसर ही नहीं करते बच्चे तो। अब बताइए
आए
10 टू
समझ
दी
में।
10 टू दी पावर 0.89 कितना हो जाएगा, 10 टू दी पावर 0.89। आपके नोट्स में सब कुछ है, ठीक है, कितना होगा रबा?
Yes, sir. 0.20 0.8 bit 0. Sorry, log of. No, there is no log in this.
देखिए log 2 की वैल्यू क्या होती है, बोलिए गाइस, व्हाट्स द
Zero
वैल्यू ऑफ log
point
2?
0.2. Sorry,
0.3।
0.3. 0.3.
ठीक है, यानी कि इस वैल्यू से आपको ये पता चल रहा है 10 टू दी पावर 0.3 इज इक्वल टू,
2.
तो अब देखिए 0.89 आ रहा है क्या, जो log का हम लोगों ने पूरा 2 से लेकर 9 10 तक लिखा था वहां पे आ रहा है क्या? 0.89 आ रहा है कहीं पे, या फिर एनीथिंग नियर टू 0.89? 0.89 एग्जैक्टली नहीं आएगा, आई एम सेइंग एनीथिंग नियर टू 0.89, इज इट कमिंग?
Log 5.
अरे यार देख के बोलो भाई, रबा आप देख के बोल रहे हैं, आपको जब सी देखिए देख के बोला कीजिए हमेशा, ठीक है ना। हम ये नहीं बोले कि आपको याद रहनी चाहिए सारी चीजें, बट आपको पता होना चाहिए आपके नोट्स में कहाँ पे है।
Sir, I'm not getting it.
आपके
But
नोट्स
I
में नहीं
think
पता ना
log.
कहाँ पे है आपको?
Yes, log 5, I guess.
नहीं वो गलत है आपका आंसर, लेकिन द इम्पोर्टेंट थिंग इज दैट कि आपको पता होना चाहिए कि आपका नोट्स में कहाँ पे, ठीक है। सो इफ यू सी 10 लॉग ऑफ 8, This is 0.9. ठीक है, एंड 0.9 इज वेरी सिमिलर टू 0.89. इसको हम क्या लिख सकते हैं? 8 इंटू 10⁻⁻1, विच विल बी इक्वल टू 0.8 माइक्रोग्राम. है ना, ए की वैल्यू निकाल रहे हैं ना, इट विल बी इन माइक्रोग्राम्स. तो 0. सॉरी, स्टार्टिंग में कितना था? 1 माइक्रोग्राम, और कम हो गया कितना हो गया? 0.8. log 7. आमना, व्हाट इज द वैल्यू ऑफ log 7? ये सामना
0.84.
0. अच्छा, आई थिंक 0.8 इज मच क्लोजर, राइट? हम्म. आमना,
Yes, sir.
log 8 विल बी क्लोजर ना. log 8 होता है 0.9, है ना? ठीक है, तो यू विल यूज log 8. प्लीज राइट दिस डाउन. मरियम खातून, क्वेश्चन. क्वेश्चन आप एनसीईआरटी, अगर आपके पास टेक्स्ट बुक है ना, एनसीईआरटी टेक्स्ट बुक में देखिए, क्वेश्चन नंबर इट इज 4.17. 4.17 या 3.17 इफ इट इज अ न्यू बुक. ठीक है, 17 नंबर क्वेश्चन ऑफ केमिकल काइनेटिक्स. क्वेश्चन नंबर 17 ऑफ द एक्सरसाइज. प्लीज quickly write this down, guys. I will give you guys 3 minutes to write this, ज़्यादा नहीं. If you can't write in 3 minutes, take a screenshot. Raise your hand if you're done writing. Okay, fine. Everyone is done. You can lower your hand, guys. Right, the next topic, pseudo first order reaction. Pseudo first order reaction. Please write a few points here. As you can see already, pseudo का मतलब क्या होता है? Pseudo means what? Fake, है ना? So please write the reaction which is not truly first order, but under certain conditions it becomes first order and is called pseudo first order reaction. And is called pseudo first order reaction. Yeah, I hope you have written this down. Now please try to understand the next point. The concentration of reactant present in excess does not affect the rate of the rate, है ना? Does not affect the rate, and hence it is not considered in the rate equation. Now, if the concentration excess में है उसमें, ठीक है, whenever we write the rate law equation, we want to understand that what reactant I should increase, है ना? कौन से reactant का हमको amount increase करना पड़ेगा? Whose concentration should I increase so that the reaction will be faster? If the reaction is already very fast, then we have to see that what reactants concentration should I increase or I should decrease so that the rate is a bit slow and then I can study the reaction more effectively. Now, if there is something which is already in excess, तो उसके कंसंट्रेशन को थोड़ा बढ़ाने घटाने का मतलब क्या है? एक्सेस मतलब इन्फिनिट आप समझ के रखिए, इन्फिनिट से थोड़ा कम कीजिए चाहे चाहे ज्यादा कीजिए, इट इज नॉट गोइंग टू चेंज द रेट. इफ फॉर एग्जाम्पल एक ए रिएक्टेंट इसका 1 मोल है और बी रिएक्टेंट इसका आपने लिया हुआ 1000 मोल्स ऑफ बी, 1000 से अगर 999 कर देंगे तो क्या ही फर्क पड़ने वाला है? That is why we are not going to consider even B in the rate law expression, because the concentration of B is not going to affect the rate of equation now when it is already in excess. ठीक है? Therefore, please write, therefore, if a bimolecular reaction, if a bimolecular reaction has one of the reactants in excess, one of the reactant in excess, then the reaction becomes first order. Then the reaction becomes first order. Write this down. Then we are going to study an example on this. Write this down. Raise your hand once you're done. And after this, you will write example जो है आप लोगों का, उसको लिख लीजिएगा. Hydrolysis of ester. ESTER. See here, guys. When we have ester plus water, it gives carboxylic acid and alcohol. It gives carboxylic acid and alcohol. So what's the formula of ester? Ester is something like this: R C double bond O, O R dash plus H2O. It's going to give you R C double bond O and OH plus R dash OH. Here water is kept in excess. ठीक है? So सुनिए जरा. Now you can see one of these reactions है ना. अगर आपको as an example लिखने के लिए बोले hydrolysis of ester, then you will write this reaction. The first and second forms are generalized form है ना, कोई भी ester. But this is a specific example. CH3CO CH3 plus water is going to give you acetic acid, C double bond O and OH plus CH3OH. Here water it is in excess. Therefore, the rate law expression, the rate इसका क्या होता है? Rate is equal to K into the concentration of ester only. Water को हम लोग नहीं consider करते हैं. Please write this down. Raise your hand once you're done writing. Seems most of you guys are done. Please write this question. See here, guys. आसान सा सवाल है. A reaction A plus B is giving product is formed to follow the following rate equation. This is the following. It is following what type of equation? This rate equation. Determine the order of reaction if B is taken in excess. Okay, then you will remember the first written here. The concentration of reactant present in excess does not affect the rate. Hence, it is not considered in the rate equation. Hence, it is not considered in the rate equation. तो यहाँ पे हमने किसको लिया हुआ है एक्सेस में? B को लिया हुआ है, and we are not going to write. We are not going to consider B in the rate equation. We'll write B, or rather, I should write this. Since B is in excess, it will not be considered. It will not be considered in rate law expression. So the rate law expression will become R is equal to K into the concentration of A only. And since the power of A is equal to 1, the order will be equal to 1. Please write this down. Raise your hand once you're done writing. Just waiting for Rabba now. Okay, and everyone is done. This was a small topic of pseudo first order है ना. Pseudo first order में बस एक ही एग्जांपल है ईस्टर वाला, वो ये ध्यान रखना है आपको. The next thing is collision theory. Please write the heading. Now, what does collision theory says? Collision theory says that collision between the reactant molecules should be taking place for the reaction to occur. It basically explains how the reaction is occurring and what are the different factors. I mean, it explains how the reaction is occurring, and according to that, how the collision theory explains that what are the factors that would determine the rate of reaction. Okay. So, what does collision theory say? Please write this with me. There must be collisions taking place between reactant molecules but every collision is not fruitful. Is not fruitful का मतलब every collision does not give you a product. Why? That we'll explain later. You'll write in the same point, next line, only a small number of collisions are effective and bring about chemical reaction. And bring about chemical reaction. Now, there are two things which controls whether the collision is going to give you a product or not. First thing is that when the reactant molecules are colliding, they should collide in a proper orientation, meaning they should collide in such a manner that the reactive sites are touching each other. And that collision should also be accompanied with certain amount of energy. If the collision or the molecules which are colliding are having very low energy, then that collision is not going to give you any reaction. So first of all, write that the necessary conditions for effective collision are: number one, proper orientation; and number two is threshold energy. थ्रेशोल्ड एनर्जी, ठीक है. अब प्लीज, व्हाट इज थ्रेशोल्ड एनर्जी? थ्रेशोल्ड एनर्जी का मतलब होता है, प्लीज राइट दिस विथ मी, द मिनिमम अमाउंट ऑफ एनर्जी, द मिनिमम अमाउंट ऑफ एनर्जी, क्या बोलेंगे, रिक्वायर्ड बाय reactant molecule for effective collision is called threshold energy. Is called threshold energy. ठीक है. Now, whenever these two conditions are satisfied, the reaction will be obviously faster and quicker, है ना. रिएक्शन वहां पे क्या होगा, आराम से हो जाएगा, and it will be very fast. So there was a question asked in a board examination quite few years ago. The question read something like this: in some cases, the reaction is found to be slow even if large number of colliding molecules have energy higher than threshold energy y. ध्यान दीजिएगा इस सवाल में उन्होंने खुद से ही बोला हुआ है that the reaction is what, reaction is slow. reaction slow हो रहा है, reaction slow हो रहा है, उन्होंने ये खुद भी बोला हुआ है that is found to be slow even if large number of colliding molecules have energy higher than threshold energy. तो minimum amount of energy तो उनके पास है, but still the reaction is slow. The only reason which can explain the slowness of reaction is the improper orientation. ठीक है, तो यहाँ पे आंसर में सिंपली आपको क्या लिखना है, ड्यू टू improper orientation of colliding molecules. ठीक है, उनका ओरिएंटेशन जो है ना प्रॉपर नहीं है, दैट इज वाई द रिएक्शन इज स्लो. बिकॉज दो ही चीज हो सकती है ना. इफ रिएक्शन इज फास्टर देन द प्रॉपर ओरिएंटेशन और थ्रेशोल्ड एनर्जी दोनों चीज होनी चाहिए. अगर स्लो है रिएक्शन उसमें से कोई एक चीज नहीं है मौजूद. राइट दिस डाउन. Let me know if someone is still writing. अब देखिए जरा. अच्छा डन ना, ठीक है ठीक है ना. यू स्टिल राइटिंग, आमना रबा नहीं ना. लेट मी नो इफ यू स्टिल राइटिंग. ठीक है. नाउ collision theory also tells, Arif Khatun, are you still writing?
No, sir.
डन ना, ठीक. सी रेट ऑफ रिएक्शन, दिस इज इंपॉर्टेंट है ना, इससे आपके सवाल आ सकते हैं. मतलब दिस इज एन अनएक्सप्लोर्ड रीजन बाय द बोर्ड एग्जामिनेशन. जनरली बोर्ड एग्जामिनेशन यहाँ से अभी तक सवाल नहीं लाया, तो असर्शन रीजन हो गया, केस स्टडी बेस हो गया, यहाँ पे इसके बारे में पूछा जा सकता है. रेट ऑफ रिएक्शन अकॉर्डिंग टू कॉलिजन थ्योरी. According to collision theory. So let us suppose we are having a reactant A and B, and it is giving us product P. So according to collision theory, the rate of reaction is given as rate of reaction is equal to, there is a probability factor P into a frequency factor Z of AB multiplied by e to the power minus EA upon RT. I'll write each and everything what is it. First of all, what is P? It is probability or steric factor. नाउ प्रोबेबिलिटी और स्टेरिक फैक्टर इट टेल्स कि अगर आपके पास मान लीजिए इसका जो वैल्यू होता है ना, ये 0 से लेके 1 तक होता है. ठीक है, अगर 0 है इसका मतलब नन ऑफ द कोलिजन इज गिविंग यू, मतलब किसी भी कोलिजन से आपके पास यू आर नॉट गेटिंग द प्रोडक्ट. ठीक है, किसी भी कोलिजन से आपको प्रोडक्ट नहीं मिल रहा है. इफ इट इज 1 देन इट मींस दैट ऑल द कोलिजन्स आर गिविंग यू प्रोडक्ट. क्या मतलब इसका, ऑल द कोलिजन्स आर गिविंग यू प्रोडक्ट. नाउ अनदर थिंग, अगर 0 से 1 के बीच में फॉर एग्जाम्पल 0.5 है, इट मीन्स दैट 50% ऑफ द कोलिजन इज गिविंग यू प्रोडक्ट. ठीक है, दैट इज द मीनिंग ऑफ प्रोबेबिलिटी फैक्टर. जेड, इट गिव्स एन आइडिया अबाउट फ्रीक्वेंसी ऑफ कोलिजन. कितनी दफा कोलिजन हो रहा है, फ्रीक्वेंसी ऑफ कोलिजन. Next we have EA, that is a new thing. EA is activation energy. EA is activation energy. R is the gas constant. Na 8.314 joules per Kelvin per mole. T is temperature. ठीक है, तो ये आपके पास यहाँ पे जो है ना मेन इसके बारे में आपको कंसेप्चुअली सवाल पूछा जा सकता है कि अगर 1 है तो उसका क्या मतलब है, 0 है तो क्या मतलब है. राइट दिस डाउन, रेज योर हैंड वंस यू डन. It seems everyone is done. Now let us understand what is the activation energy here. Please write the topic. Activation energy. What is activation energy? Please write. It is the extra energy required by reactant molecules to achieve the threshold energy. So what is activation energy? It is equal to the threshold energy minus the average energy of the reactant molecules. ठीक है, तो see, the reactant molecules will be having some energy na? Each and every body, each and every object, each and every substance in this complete universe have certain amount of energy in itself, है ना. किसी के अंदर भी एनर्जी जीरो नहीं है. Now whatever energy, the extra energy that you require for the reactant molecules to achieve threshold energy, उसी को बोलेंगे activation energy. तो जब activation energy मिल जाएगी, then that reactant molecules can further react. ठीक है, अब अगर हम बात करें इसी के बारे में, एक्टिवेशन एनर्जी के बारे में, ध्यान दीजिए जरा. आपके पास वी आर गोइंग टू प्लॉट कि कितनी एनर्जी रिएक्टेंट के पास रहती है, एंड देन वी आर आल्सो गोइंग टू सी कि कितनी एनर्जी रिक्वायर्ड होगी. नाउ प्लीज सी हियर, डोंट राइट. लेट अस सपोज दैट द रिएक्टेंट मॉलिक्यूल्स आर हैविंग दिस मच अमाउंट ऑफ एनर्जी एंड दिस इज द थ्रेशोल्ड एनर्जी. ठीक है, दिस इज द थ्रेशोल्ड एनर्जी. सो द रिएक्टेंट मॉलिक्यूल्स हैव टू इंक्रीज देयर एनर्जी ना, उनको अपना क्या करना पड़ेगा, एनर्जी को इंक्रीज करना पड़ेगा. then their energy will increase, it will reach the threshold energy. उसके बाद रिएक्शन होगा एंड देन रिएक्शन के बाद फिर आपको प्रोडक्ट मिलेगा. अब प्रोडक्ट मिलने के लिए आपके पास दो केसेस है, या तो एनर्जी ऑफ प्रोडक्ट इज लोअर देन दैट ऑफ द रिएक्टेंट, जैसे कि इस केस में है. ठीक है, तो ब्लू वन क्या है, एनर्जी ऑफ रिएक्टेंट, एंड द ग्रीन वन इज द एनर्जी ऑफ प्रोडक्ट. नाउ इफ आई ड्रॉ लाइन हियर लाइक दिस, ठीक है, एंड आई ड्रॉ लाइन हियर, अभी आप लोग ना प्लीज कुछ मत लिखिएगा. ठीक है, Now, this energy, this is known as activation energy. ठीक है, बिकॉज रिएक्टेंट के पास इतना एनर्जी था. दिस इज द एक्स्ट्रा अमाउंट ऑफ एनर्जी ना जो पिंक लाइन में हमारे पास है. देन दिस एनर्जी, the energy between the reactant and product, this is known as delta H. That is the enthalpy of reaction. So these are the important things that you need to understand. यहाँ पे आपके पास this is potential energy and here we have reaction coordinate. अब देखिए, अब यहाँ पे ना एक और चीज हो सकती है. When the energy of product is more than that of reactant, ठीक है, उस केस में कैसा होगा उसको जरा देख लीजिएगा. I'll have to erase this part. ठीक है, in this case what is there, as you can see the reactant molecule, sorry, the energy of reactant is lower than that of product, है ना. अब आपके पास जो curve होगा, the curve would look something like this. Now this is the activation energy still. The energy between reactant and product, this is still delta H. ठीक है. Now important thing यहाँ पे जो है आपके पास एक बहुत ही ज्यादा, that is this point. ये जो point है ना आपका, this point, the point at which the energy is highest, इसको बोलते हैं transition state. Transition state. ठीक है, this point. चलिए, please draw these two. Raise your hand once you're done. In the next class, Parker, inshallah. Please raise your hand if you're done writing. चलिए, see here guys, in the first case if you see, we talk about delta H here, then delta H is the energy of product minus the energy of reactant, है ना, फाइनल माइनस इनिशियल. सो यहाँ पे प्रोडक्ट की तो एनर्जी कम है, राइट, इट इज लोअर एंड रिएक्टेंट की ज्यादा है. सो ऑब्वियसली द डेल्टा एच दैट वी आर गोइंग टू लुक विल बी नेगेटिव, एंड इफ इट इज नेगेटिव द रिएक्शन विल बी एक्सोथर्मिक. Here if I look at delta H, then in this case energy of product minus energy of reactant here also, because final minus initial. So delta H in that this case product की एनर्जी ज्यादा है और reactant की क्या है, कम है. Did some mistake? हाँ नहीं, ठीक है. So this will be positive and the reaction will be endothermic. With this, write some remarks. When activation energy is higher, the reaction is slow because उसको ज्यादा टाइम लगेगा activation energy threshold energy achieve करने में. When activation energy is lower, the reaction is fast. Then write when colliding particles possess energy that is equal to activation energy, then the atomic configuration is called transition state or activated complex. ठीक है, ट्रांजिशन स्टेट के बारे में फॉर एग्जांपल अगर आप देखें, वी हैव हाइड्रोजन प्लस I2, H2 प्लस I2, है ना, ऐसा कुछ देखिएगा. Now when the reaction is occurring, then hydrogen and iodine will be making a bond, और हाइड्रोजन हाइड्रोजन का बॉन्ड क्या होता रहेगा, टूटता रहेगा. So please see, I am showing you guys the breaking of bond as the red. The hydrogen hydrogen bond is breaking, the iodine iodine bond is breaking, and I'm showing it in green, the formation of Hi bond. Hi bond is forming. Now this state is known as transition state, or it is known as activated complex. After this, what is going to happen, you will form 2 moles of Hi. Okay, please write this down. Raise your hand once you're done writing. Just waiting for Rabah. Okay. Everyone is done. See here. Now, there is a homework that you need to do in your notes. There is a small section of Maxwell Boltzmann distribution, in which you will see a graph which is like this. Okay. You just need to read that and make a bit of notes. ठीक है, about just one plot. ठीक है, just about one plot. वहां पे उन्होंने बस basically ये बताया हुआ है that most of the molecules that are taking part in reaction, they don't have high energy. ठीक है, तो यहाँ पे उनकी kinetic energy plot किया हुआ है, यहाँ पे they are plotting the fractions of molecule. So very less amount of molecules are having this is if this is the threshold energy. तो बहुत ही कम molecules होते हैं जिनके पास threshold energy होती है. That is why we need some kind of activation energy. ठीक है. Now this is the only crux of Maxwell-Boltzmann distribution. एक बार आप उसको नोट से मतलब बुक से अगर लिख लेंगे then it will help you guys to remember it also. Next is factors affecting rate of reaction. Now, there are certain factors that we have already covered. The first one is the most important, concentration of reactant. Concentration of reactant. And obviously, concentration of reactant, it is a factor and it also depends on the order of reaction. But in general, we can say that the rate increases with increase in concentration of reactant. Increase in concentration of reactant. Second is the physical state of reactant. Whether the reactant is solid, liquid, or gas, that is also going to affect the rate of reaction. Then obviously temperature. We are going to learn in detail. Temperature is the only factor that is there in detail after the concentration. Then we have catalyst. The fifth is surface area of solid. And sixth is pressure for gaseous reaction. Okay. Now, in this cases, we have already done concentration of reactant, which is important. Temperature is another thing which is important that we are going to do. Catalyst is we have already done. Catalyst is something that is also important and we have to understand it. The rest of these things, physical state, surface area of solid and pressure of gaseous reaction, these are not very important. जिसको NCERT ने ऊपर से मतलब टच भी नहीं किया है. They have just written 1 or 2 sentences about it. That's it. ठीक है. So concentration of reactant we have already done. So we'll start with the second one, that is the physical state of reactant. So the factors affecting the rate of reaction. So सबसे पहला जो हमारे पास हेडिंग आएगा that will be physical state of reactant. As we know, the rate of reaction is going to depend on the collision of different molecules, and obviously the collision will be very smooth and the collision will be also having proper orientation if we are having same type of reactant. Either all of them are in solid state, all of them are in liquid, or all of them are in gases. The first thing is that rate of homogeneous reaction is greater than rate of heterogeneous reaction. Homogeneous reaction means all the chemical species involved in the reaction are in the same phase or same state. Hetero का मतलब अलग-अलग phases में. Now, obviously, since homogeneous is the winner, then let us look at in homogeneous reaction, what combination is going to give you the fastest reaction. So for homogeneous reaction, we can say that the solid plus solid, they will be having the least amount of movement. That is why if the reactant is solid, we're going to have the slowest reaction, followed by liquid plus liquid, and followed by gas plus gas, which will be having the highest rate of reaction, because obviously the gaseous particles, they move very rapidly. The next is temperature that we have to discuss. Although we are going to learn about this temperature in great detail in the next class, but एक simple सा आप ये कर सकते हैं, as temperature increases, kinetic energy of reactant increases, therefore number of effective collision also increases, which leads to increase in rate of reaction. So we can say that the rate of reaction, it is directly proportional to temperature. If temperature is high, rate of reaction will start getting faster. Next is catalyst. Catalyst is important, ठीक है ना, इसको ध्यान से भी पढ़ेंगे. हमारे पास देखिए टेम्परेचर तो हम लोग पढ़ने वाले हैं नेक्स्ट क्लास में जरूर से, बट कैटलिस्ट इज वेरी इंपॉर्टेंट. ध्यान से लिखिए द टॉपिक कैटलिस्ट. Write the topic catalyst. Now, what is a catalyst? Write the definition and then you will understand the working. Please write this. Catalyst is a substance which increases the rate of reaction without going or without undergoing permanent change. Without undergoing permanent change. Okay. Now please listen, don't write anything. ध्यान सुनिएगा. Let us suppose we are having A and B. ठीक है, इससे मिलके आपको देना है एक प्रोडक्ट. द प्रोडक्ट इज AB. Let us suppose we need AB, we are in heavy requirement of AB, but both A and B, these are stable molecules. They are stable, meaning that they are not very reactive, they are unreactive molecules. So obviously the reaction will be what? Slower, है ना. तो reaction क्या हो जाएगा? बहुत slow हो जाएगा, because both of the reactive molecules are very stable. दोनों के दोनों reactive molecules क्या है? काफी ज्यादा stable है. Now what we do? We introduce a very reactive molecule. क्या? We have A plus B plus C, and this C is what? It is very reactive. और ये इतना रिएक्टिव है that it reacts both with A and B, and ये कुछ इस तरह का बॉन्डिंग करेगा. This is C, and it will make a bond with A and it will make a bond with B also. Now you can see that A and B पहले free state में थे, now they are bonded with the C part, the C element, and obviously their stability will be a bit disturbed. Another thing that will happen is that they are now a bit closer to each other, right? So the new bond formation between A and B will be easier. A और B को C ने क्या बना दिया? Reactive बना दिया, and it has brought both of them closer also, and hence this AB reaction will be much faster now, and then C will be removed as it is. देखिए C जो है, it is taking part in the reaction, but C product में it is present as C itself, so it is not undergoing permanent change, but temporarily it is changing, है ना. ऐसा नहीं कि देखिए बहुत जगह ना ऐसे डेफिनेशन लिखा दिया जा सकता है that they will write something like that: catalyst is a substance which increases the rate of reaction without taking part in the reaction. But that is not a true statement, because it is taking part. It is not going to take part in a reaction, then how it is going to affect the rate of reaction? It does take part in the reaction, but it does not undergo permanent change. Temporary change जरूर होता है. There is some temporary change happening, and that is why only it is going to increase the rate of reaction. ठीक है ना. Let us see. अब ये आपने समझ लिया ना किस तरह से करता है. आपको एक चीज यहाँ पे दिख रही होगी, दैट इट इज गिविंग द रिएक्शन अ कंप्लीटली न्यू पाथ, इज गिविंग अ रिएक्शन कंप्लीटली न्यू पाथ। पहले ए और बी था, ये इस तरह का कॉम्प्लेक्स यहाँ पे बीच में नहीं बन रहा था, राइट, है ना। इट इज गिविंग अ न्यू पाथवे फॉर द रिएक्शन, इट इज गिविंग न्यू पाथवे फॉर द रिएक्शन। तो ध्यान से लिखिएगा आप यहाँ पे, if you want to make, you can write these two lines and then you will write catalyst provides a different reaction pathway with lower activation energy। स्टेबल मॉलिक्यूल को एक्टिवेट करने में बड़ा एनर्जी लगेगा, सिंस वी हैव अ रिएक्टिव सी, तो एनर्जी यहाँ पे क्या लगेगी, कम लगेगी, है ना, लोअर एक्टिवेशन एनर्जी, एंड देयरफॉर increases the rate of reaction। After this, we'll make this diagram. Then raise your hand and start writing. Mariam Khan, can you please go to the Learnivio app? There you will see an assessment.
I'm doing that.
Achha, you're Achha, very good.
Sir, I won't be able to give assessment today.
Achha, it's fine, not a problem. ठीक है. Is everything fine, Rabba?
Yes, everything is fine. My mother went to hospital with one of my cousin, so that's why
Achha.
I don't have the phone.
Achha, so you don't have the phone, okay, fine. Okay. What about others? Amna, Parker, Mir, Rabba? Oh, sorry. Raise your hand if you're done. Sidra.